Right, similar triangles question. We have this shape here. AB is parallel to CD. The first thing we need to do is prove that triangle ABX is similar to triangle DCX. If two triangles are similar, then one is just an enlargement of the other one, which means that the angles in the first triangle must be the same as the angles in the second triangle. So the easiest way to do it is to look for angle properties. As these two lines are parallel, we can say that this angle here is the same as this angle here. It's like a Z shape, but technically it's called alternate angles. So the first thing we can write down is that XAB, put a little hat on the A to show that's where the angle is equal to XDC, and we have to write the reason down, and the reason is alternate angles. Another pair of angles which are the same are this angle here and this angle here, because they're on an X shape like a cross. They're called opposite angles. So AXB, so AXB is equal to CXD, CXD, and that is opposite angles. Now, if you've shown that two angles are the same, then the third angle has to be the same as well, because the angles in the triangle add up to 180. But these two angles are the same. Again, it's alternate. But showing two is enough. So therefore, triangle ABX is similar to triangle DCX, and the reason angle, angle, angle. All the angles are the same. Once we know that this triangle is similar to this one, then we also know that this is an enlargement of this one. So what we need to do next is to try and find out what the scale factor of the enlargement is. And the easiest way to do that is to look for two corresponding sides. Now, corresponding means they're between the same pairs of symbols, effectively. So this side here is between the dot and the X, corresponds to this side here between the dot and the X. This side here between the arc and the cross is the same as this, corresponds to this. So these two here we've got lengths on, so these two are corresponding. Arc, dot, dot, arc, so they're corresponding. So to find the scale factor, well, what do you times 4 by to make 6? Well, the easiest way to find that out, if you don't know already, is to divide the biggest by the smallest. So the scale factor here is times by 6 over 4. If I stick that into my calculator, 6 divided by 4 is 1.5. You can do it as a fraction or as a decimal, makes no difference. So if I want to find the length of CX, well, it corresponds to XB, so it's going to be 3, and because it's getting bigger, times by the scale factor. So 3 times by 1.5, which is 4.5 centimetres. If I want AB, well, AB corresponds to CD, so I'm going to use this 9 centimetres. But as we're going from big to small, rather than multiplying by the scale factor, when I go from small to big, I divide. So do 9 divided by 1.5, which is equal to, if you can't do that in your head, 9 divided by 1.5, 6 centimetres.